Arvin Ride Control Products Incorporated, makers of Gabriel heavy truck shocks, is a worldwide leader in ride control technology. As a matter of fact, we introduced the first shock absorber way back in 1907 for lorries, the trucks of that day that were used for shipping goods to market. Items made out of wood, porcelain, and glass were being damaged. The roads of the day were riddled with potholes and ruts, roads that were little more than cow paths. Something was needed to slow down and control the movements of the suspension so that the goods could reach the market undamaged and in saleable condition. Gabriel answered that need in 1907 with the introduction of the first shock absorber, the snubber. The snubber was a simple device that used mechanical friction to slow the oscillating movements of the vehicle. As vehicles became heavier, faster, and more sophisticated, something else was needed, something more efficient. And in 1918, Gabriel answered that call with the introduction of the Aerotype hydraulic shock absorber, the first shock absorber to use the displacement of hydraulic fluid through small valves, creating resistance, damping the suspension movement. These basic hydraulic design principles are still in use today. Creativity and innovation have always been the mainstay of Arvin Industries and Gabriel. In 1956, we introduced the first adjustable shock absorber, a product not only on the leading edge of technology for the day, but of such enduring quality that it has been incorporated into the modern-day design of Arvin's premium heavy truck shocks. Satisfying the needs for a broad range of markets, our creative innovations continued with the introduction of twin-tube gas shocks in 1983 and VST, Velocity Sensitive Technology, in 1995. You can be sure when new technologies and innovations are introduced, Arvin Ride Control Products will be at the forefront, committed to the heavy truck industry. Arvin Ride Control Products Toronto is the specialty shock absorber manufacturing division within the Arvin Ride Control Products Group. Our plant is located in Toronto, Ontario, Canada. Our focus is on the heavy truck, trailer, bus, recreational vehicle, military, and industrial shock absorber markets worldwide. We are a premier manufacturer of OEM shock absorbers to the global heavy truck industry, supplying manufacturers such as Freightliner, Kenworth, Peterbilt, Western Star, Volvo, Hendrickson Suspensions, New Way Suspensions, Link Cab Suspensions, Bostrom and Sears, as well as many others. The following video will explore the fundamentals of shock absorber inspection and replacement procedures within the heavy truck industry. To better understand this process, it is necessary to understand what a shock absorber is and what it does. A shock absorber's job is simple. They do not support weight, they control the movement of weight. Shocks slow the up and down movements of the vehicle's sprung mass, keeping it in control. Sprung mass is the weight supported by the suspension springs. For example, the vehicle's body, frame, motor, and transmission would be sprung mass. Unsprung mass is the weight that is not carried by the springs, such as tires, brakes, and axles. The role of the shock absorber is also to limit the number of times the suspension moves up and down for each impact encountered by the vehicle's tires. Most people think shocks are primarily for driver comfort. While it is important to reduce driver fatigue, it is not the principal job of shock absorbers. The control or slowing of weight movement from rear to front during braking ensures proper contact of the tires with the road, reducing stopping distance. Control of the weight from side to side helps distribute the weight evenly, promoting straighter stopping, reducing loss of directional stability, and the possibility of swerving. Shock absorbers in good working order control the movement of weight as the vehicle is driven. They reduce side-to-side motion and control the constant oscillations of the vehicle, making the vehicle easier and safer to drive, as well as reducing dangerous driver fatigue. Limiting the number of oscillations or up and down movements of the vehicle reduces wear of suspension and other critical truck components. Movable joints comprised of either rubber or urethane combined with steel connect all articulated or movable suspension parts. If we can limit the number of times the vehicle moves up and down, all articulated parts will move less, resulting in a longer operating life. Tire wear is also affected by the condition of the shock absorbers. Worn or ineffective shocks can increase tire cupping, which will reduce the useful service life of the tires. tire replacement caused by a shortened service life is a major expense that may be avoided. There are many components on a truck that can fail prematurely because of excessive vibration or the constant pounding of an undampened suspension, such as sensitive electronic components, cab accessories, lights, air conditioning, refrigeration units, and radios. It is important to note the shock absorber acts as a filter to the suspension, limiting harmful road inputs. The shock absorber is a wear item designed to protect other more expensive components on the vehicle from failing prematurely. Multiple leaf spring designs are high-friction suspensions, which may have only 2 to 3 inches of suspension travel. This type of suspension has a much higher level of friction and moves much slower, requiring little damping from the shock. This is due to the spring absorbing the majority of the vehicle's oscillating energy. On this type of suspension, the shock is more of a vibration damper than a motion control device. Because of today's low-friction suspensions that offer much longer suspension travel and are more compliant, the shock absorber has become more important in providing cargo protection, better vehicle control, and reducing driver fatigue. According to the Ride Wear and Safety Study SAE 962152, air ride suspensions with properly functioning shock absorbers experience load equalization that is 35% better than that of steel suspensions. Further, air ride suspensions with good shocks reduced peak tire loading by 2 to 3 times that of air ride suspensions with worn shocks. This is very important for reducing tire and suspension wear, as well as protecting the cargo and road bed from impact damage. Because of the increased load capacity demands of air ride suspensions, shocks have more work to do. They work harder, so it's even more important that shocks are in optimum operating condition. There are 2 methods that can be used to determine when shocks need to be replaced. First, asking qualifying questions, and second, physical inspection of the vehicle and the shock absorber itself. Using the proper questioning technique is important to get useful information. Open-ended questions like, "How does your truck ride?" or "How does your truck handle?" are not specific enough to get usable answers. Most drivers think their trucks ride and handle adequately. You need to ask specific performance questions.
Do you notice the vehicle sway back and forth when you change lanes? When you have to slam on the brakes, do you ever experience tire chatter? When you brake hard, does it pull left or right? When you go over an expansion joint or hit a dip or a bump in the road, does your truck continue to oscillate, bounce up and down and transmit excessive shock through the steering wheel or through the seat? Now, do you drive mainly on highway, off highway, city driving, or long haul? What types of trailers are being hauled? Are multiple trailers ever hauled, like vans or tankers? What types of loads do you transport? Are the loads you carry constant, or do they vary from trip to trip or season to season? And how many miles are driven yearly? When was the last time you had the shocks replaced?
This type of information will help you determine what type of shock is appropriate for the particular situation. Vehicle inspection can be your most valuable tool in determining the true condition of the suspension and should be included in your fleet's regular maintenance program. Most shock absorber replacements are based on the technician's recommendation. Therefore, a complete and thorough inspection is critical. Shock absorbers function at temperatures ranging from ambient to as high as 350 degrees Fahrenheit. A shock absorber's role is to dampen the oscillation of the vehicle, controlling the up and down movements of the sprung mass. It does this by restricting the movement of fluid through a series of valves. This resistance creates friction. Consequently, the shock should be warm or hot to the touch after normal use. The following are the proper procedures for a shock absorber heat test. Number 1. The vehicle must be driven at a moderate speed for at least 15 minutes, preferably on a road that is rough or has bumps and dips, one that will make the shocks work. A non-contact thermometer may be used and is recommended to ensure the most accurate temperature reading. Within a few minutes of driving the vehicle, and after first touching or measuring a nearby part of the chassis to establish a reference for the ambient temperature of the metal, touch or measure each shock absorber on its body, below the dust tube. Be careful, it may be hot. Number 2. All shock absorbers should be warmer than the chassis. Suspect a failure if a shock absorber is noticeably cooler than the chassis or its mate on the other end of the axle. Differing shock temperatures from axle to axle do not necessarily indicate failures. However, cooler temperatures between shock absorbers on any single axle warrants further inspection. Number 3. To inspect for internal failure, remove and shake the suspected shock. Listen for the sound of metal parts rattling inside. Rattling metal parts can indicate that the shock has an internal failure. Look for leaking shocks. You must determine if the shock in question is leaking or misting. Misting is a normal occurrence within the heavy truck industry. As the piston rod enters the shock during compression, hydraulic fluid adheres to the piston rod, lubricating the piston rod seal during extension. When the shocks are functioning properly, they generate heat. When they become hot enough, the fluid adhering to the piston rod evaporates into the atmosphere, forming a light mist underneath the dust tube. It then cools and condenses back onto the upper portion of the shock, approximately 1 to 2 finger widths below the top of the shock body, leaving a fine oily residue. A misting shock will have no residual oil within the measured area of the upper portion of the shock. When a shock is leaking, the upper rod seal has been damaged, allowing a flow of fluid to leak out. This may occur when the shock has experienced excessive side loads or the piston rod has become corroded or pitted, or perhaps the rod seal is simply worn out. If the shock absorber is leaking, it must be replaced. It is no longer functioning properly. It cannot be repaired and it will not heal itself. Shocks that are gas-charged typically have a dimple located on the upper portion of the shock body beneath the dust tube. To check if the shock is charged to its designed operating pressure, fully collapse the shock. The shock should extend quickly to its full length. If it does not fully extend, replace it. Gas cell shocks offer all the features of conventional hydraulic design with the added benefit of a sealed gas reservoir. The gas cell design is a more absolute method of eliminating the effect of aerated or foaming shock fluid, rather than coping with it as gas-charged shocks do. If a gas cell shock is suspected of failure, remove the shock. Hold the unit in a horizontal position, stroking it back and forth. If a lag or air pocket is present, replace the shock. Worn or damaged bushings, broken or damaged end mounts mean the shock was not solidly connected to the vehicle at both ends. It could not function properly and has physically failed. It is important to fully inspect and ensure that all shock mounts are within spec. Look for dents on the shock's body. Severe dents can restrict the piston rod movement. A broken or bent piston rod is also a physical failure. The shock cannot function properly in this condition. Anytime a shock has physically failed, immediate replacement is required. Worn shocks will allow excessive, uncontrolled movement of the vehicle suspension, causing accelerated suspension and chassis component wear. Cab accessory, light, electronic component, and refrigeration unit failures can also be caused by ineffective shocks. Tire wear can be adversely affected by worn or ineffective shocks. Tire cupping can be caused by constant repetitive up and down oscillations of the vehicle as it is being driven. As the vehicle is driven and is moving up and down, weight changes on the tires cause uneven wear patterns to develop, creating the cupping pattern. This type of wear will drastically reduce the tire's useful tread life. It is critical to make sure that the height adjustment for air ride suspensions fall within the specifications listed by the manufacturer of the particular system. Improper ride height will adversely affect the performance of the suspension and possibly reduce the service life of the shock absorber. Torn or damaged air springs may indicate a worn or ineffective shock absorber. Shocks limit the speed of air spring extension as well as limiting the length of the extension. To help maintain the maximum life of the air spring, it is essential that shocks are in proper working order. Worn or ineffective shocks can contribute to the premature failure of full taper leaf springs. Improper ride height, sagging springs, or poor ride quality are early signs of full taper leaf failure. Periodic inspection and proper maintenance is essential in maintaining correct suspension performance alignment. Worn spring bushings and pins will shorten the shock's operating life due to excessive suspension and axle movement. Shocks are the first line of defense in the protection of both air and full taper leaf springs. Mileage is not the sole criteria for replacing shock absorbers. It is a common sense guideline. A vehicle with high mileage is more likely to have worn shocks that are not operating at peak efficiency. More mileage equals more wear. A preventive maintenance program utilizing the proper inspection process is a valuable tool in determining the condition of the vehicle's shock absorbers. Keeping track of when shocks are replaced will establish a trend and help determine a good replacement cycle for a given vehicle or fleet. If a shock has become worn and has exceeded its intended service life, it is advisable the shock located on the other end of the axle be replaced. Vehicle inspection is the key to success. No other method will give you as much information about the vehicle's condition. Every vehicle that is serviced should be thoroughly inspected every time it comes in. You never know when the evidence of worn shocks will be present. The most important thing to remember is consistency. Inspect every vehicle every time. Shocks need to be replaced before they fail. After determining the need to replace the shock absorbers, correct utilization of the catalog is vital to ensuring the proper shock is used. The heavy-duty shock catalog is sorted alphabetically by cab and specialty products shocks, light truck shocks, medium and heavy-duty truck, and trailer and bus applications. In addition, the catalog has numerical listings by product type, mounting accessory packages, and interchange listings for the competitive products and original equipment manufacturers. Looking up applications is relatively simple. However, you must pay attention not only to the vehicle type and make, but also to the type of suspension used. Close attention should be paid to any footnotes included in the application listing. The correct shock may also be found using the competitive or OEM interchange listings. All you need is the part number from the old shock, then refer to the interchange for that particular manufacturer. It should be noted, when replacing shocks on the vehicle, referencing the OEM part number is the preferred method. Sometimes it is necessary to measure a shock to determine what part number you need. Refer to the How to Determine the Correct Shock for Your Truck section in the catalog. The instructions should be carefully followed to ensure the proper shock is used. When measuring a shock for use on air-ride suspensions, it is important to be sure the replacement shock absorber is no more than 1/4 inch longer than the original shock fully extended, nor 1/4 inch shorter than the original shock fully compressed. Again, refer to How to Determine the Correct Shock for Your Truck section of the catalog for measuring instructions. Before attempting to remove the shocks, be sure the vehicle is properly supported and secure. When removing the shock, note the type of mount and the order of the mounting hardware so reassembly is performed correctly. Incorrect reassembly can almost ensure premature failure of the shock. Check for instructions that may be enclosed with the hardware kit. These are included when special attention is required. Do not twist off studs or bolts. If the nuts are rusted, use penetrating oil on threads, allowing the oil to penetrate before removing the nut. If the penetrating oil does not work, the use of a nut splitter is recommended. Careful attention must be paid not to damage the mounting threads if the stud is part of the vehicle. When servicing shocks with I-ring sleeve mounts, make sure the old sleeve has been removed. It may be frozen on the stud. It must be removed and replaced with the new sleeve supplied in the hardware kit. The mounting bolts should also be cleaned. The new units are installed in the same position and manner as the original equipment. The upper mounting should be installed first with the dust tube at the top. The lower mount is then attached. Do not over or under tighten the shock bolts. Shocks with an I-ring bushing type mounting are simple. Remove the shock absorber by removing the attachment hardware and clean the mounting area. Always use new bushings. It is not good practice to reuse the old bushings. The upper mounting should be attached first with a dust tube at the top. It is very important to correctly mount cupped metal washers so that the concave side is pointing away from the bushing. This will ensure the shock I-ring can flex properly, ensuring longer shock absorber life. Take care not to over or under tighten the shock nuts. The rubber bushing should not be squeezed so that its diameter is larger than that of the metal washer. Rather, refer to the mounting code I-ring and bushing section of the catalog for the correct compressed length of the appropriate I-ring and bushing type. A shoulder on the mount stud should prevent over-torquing. Ensure that the correct shoulder bolt is being used. The lower mount is then fastened, again paying close attention to the bushing and washer configuration. If a shock absorber is functioning properly, but the rubber bushings have worn out prior to the shock's useful service life, service kits are available to replace them. Check the heavy-duty shock catalog for availability. Polyurethane bushings should not be used unless they are supplied with a shock absorber. Polyurethane bushings are very rigid and may create a non-flexible mounting. This can accelerate end mount and piston rod seal wear due to increased side load forces. Most shock absorbers are not designed for polyurethane bushings. When working on stud mount shocks, remove the shock attachment nut, washers, and bushings. Then, remove the shock. Inspect to make sure the mount for the shock stud is not elongated and falls within spec. Special attention must be paid to the installation of the bushings and concave washers. It is different than the I-ring bushing mounting. Install the lower metal washer on the shock with the concave side up. Slide the bushing down the stud so it contacts the metal washer with the raised portion of the bushing pointed upwards. Slide the shock stud up through the mounting hole on the vehicle. Then, slide the second bushing down the shock stud until seated on the metal mounting of the vehicle with the raised portion of the bushing facing down. Place the metal washer on the upper bushing with the concave side down. Do not over or under tighten. The nut should be tightened until the rubber is the same diameter as the metal washer. Then attach the lower mount in the same way. Double check to be sure all fasteners have been correctly installed and that they are tightened properly. Make sure the washers and bushings are mounted in the correct orientation to the specific shock end mount. Check to be sure that the shock absorbers do not come in contact with the frame, air springs, steel springs, taper leaf springs, or any other components of the suspension. Remember, one of the primary reasons for premature shock failure is due to incorrect installation or misapplication. The following are some special circumstances that need particular attention. Lift self-steer axles, auxiliary liftable steerable systems, booster axles. Pusher axles and self-steering axle suspension systems require highly specialized shock absorbers. These shocks may include coil-over springs or specific end mount designs. It is of vital importance that the correct specialty application shock absorber is utilized to ensure the safe operation of the particular system in use. The procedure for adjusting Arvin's adjustable heavy truck shock absorber is simple. Fully compress the shock, grasp the dust tube, and then rotate the bottom portion of the shock in a counterclockwise direction until you hear the piston's adjusting cam click into position. The shock absorber's body is stamped with an arrow which points to printed adjustment indicators found on the clear label. F indicates firm, which is similar to factory-equipped specifications. XF, or extra firm, increases the resistance, making the shock firmer than OE specifications. R indicates regular and is somewhat softer than the factory setting. Once the desired setting is selected, extend the shock at least 1 inch to activate the setting. On some truck suspensions, it is possible to adjust the shock without completely dismounting it. Loosen the lower mount, remove the lower portion of the shock, compress fully, then adjust and reinstall. Appropriate protective measures such as wearing safety glasses and protective gloves should be taken when removing oil and gas from discarded shock absorbers. First, using a vise, secure the shock absorber in a horizontal position. Fully extend the unit and drill a hole through the body of the shock absorber approximately 1 inch from the bottom. Drill a second hole approximately 2 inches from the top of the shock absorber. For gas-charged shock absorbers, it is important to cover the area where the hole is being drilled with a towel or other protective shield to prevent spraying gas and oil upon the initial penetration of the drill bit. By stroking the shock absorber back and forth, you will purge all of the oil. Store the used oil in an approved container clearly marked Used Oil. Dispose of the used oil in accordance with EPA's state, provincial, or local regulatory agencies. Remember, proper, thorough inspection and careful professional installation of shock absorbers will increase the useful life of many of the truck's components and reduce the cost per mile operation. Arvin Ride Control Products, a worldwide leader of ride control technology whose shocks are chosen as original equipment by many of the world's leading manufacturers of heavy trucks, will continue to strive to exceed our customers' expectations. You can be assured that when it comes to manufacturing products that deliver high on innovation and value, Arvin is committed to the heavy truck industry.